Okay, hey folks, we're going to get started now, I guess. So, hi, I'm Ben, and this is the Step Up to Style Guides. Yeah, hi, I'm Ben Scott. I'm a web developer who works at the BBC. In particular, I work on the /program site. We're the permanent archive of everything that's been broadcast on the BBC in the past 8 years. We've got literally everything from the past 8 years, and then selected stuff going back even further than that. So, for instance, we've got things like Desktop and Discs going back to 1942, and the oldest playable piece of media we've got on the website is a drama adaptation of The Sword in the Stone that was originally broadcast in June 1939, and you can go back and you can listen to this. That's not actually relevant to this talk. I just think it's quite cool. It turns out if your mum's a librarian, you quite like the whole idea of publicly accessible data sets, and somewhat unsurprisingly, as a dev, I'm not a big fan of the whole unneeded repetition thing. I'm not just talking about the whole writing dry code, don't repeat yourself stuff, but also in terms of language and how we communicate as well. So jargon is the special words or expressions used by a professional group that are difficult for others to understand. And this is traditionally a pretty negative term, and when it's used poorly, it can exclude people. We've all heard scenes of techno-babble where people say a bunch of words that no one understands, and you just kind of go, what? So actually, boo, jargon, bad idea. But actually, when it's used properly, when everyone knows what those pieces of jargon mean, or at least can easily look them up, then it's a tool to enable efficient and streamlined communication between teams. It reduces the amount of time needed to express particular precise ideas, and it reduces the scope for mistakes as well. So actually, it turns out, yay, jargon is quite a good thing after all. And this is essentially the ideology behind design systems. You and your team agree upon a standard way that you want your brand to be presented, what colors you use, what typefaces, what font sizes, how you want to represent your common domain objects. So for instance, we have a program object that says here's a title, here's an image next to it, here's when it was on, that we use in like aggregation pages like A to Z listings, things like that. And you take all these ideas and you give them names, and by giving them names you actually gain a whole load of power over them, because you stop having to talk about what something looks like and its properties, and instead you start talking about what it is, its innate thatness. So, for instance, if I said, oh, this block of text on a page should be, what's that, F54997, you kind of shrug and go, what? That's a color code, that means nothing to me. But if I told you actually that block is iPlayer pink, there's half a chance you might know what I'm talking about, or at least you would in the UK, where iPlayer is like one of the most recognizable brands in the country. So, going further than that, if we say, okay, here's a bit of responsive typography, it's going to be font size 15 pixels, line height 18, changes to 16 and 20, and then changes again to 14, 18. You look at me completely boggle-eyed and go, what? That's nonsense. That's a whole load of incredibly specific information that I've got to remember. But if I said, oh, that's just the BBC Gel default text size, you kind of go, okay, yeah, I can live with that. That's an understandable nugget of information. Because you know that you don't need to remember all those exact values every single time. You know that you can look them up when needed, and you just need to know, oh yeah, that's the base font size, and I can go and look up what it is a little bit later. This also works well with larger items beyond colors and text sizing as well. So imagine someone trying to describe an entire page layout to you. All the pieces of data to be displayed, their positioning relative to each other, all of the font sizes. It'd be completely overwhelming to the point where you go, no, give me a picture instead. And it ends up looking something like that. Good, it has displayed on funky big screens. But if someone told me, oh right, this page should have 24 program objects in them, laid out in a 3-column grid at the large breakpoint, I'd be pretty happy implementing that. I mean, I know that's a program object, I know it's got a title, it's got an image, it's got a synopsis, it's got a duration, I know it's got a little link that says, oh hey, click on me to go and play this piece of media out. I don't need to see that design because I know everything that's contained within it. I know what the standard grid looks like. I don't need that full image. The words are enough. So design systems are a mechanism for standardizing the patterns that you have. So you can talk about things and say, it's a program object rather than all of those precise bits of positioning. And these things become standard ideas, and they help enforce consistency within your team. If someone shows me a mock-up with a different shade of pink, I'd ask them, is there a reason you're not using the standard pink color? Same if there's some non-standard text as well. And often there are really good reasons for deviating from your standard design system that already exists, and it's okay to break away from it, but having it there in the first place helps you ask, why does this need to be different? James was just in here before talking about accruing technical debt, and you can't spec out an entire design system on the very first try. You can say, right, here's what we need right now, and then if there are new items, then you can go and add to it later as soon as you understand your use cases for these particular things. So if that deviation is justified, and you say, right, okay, here's a new pattern, it's worth adding to my design system, document saying, hey, here's why it's different, here's why it deserves to be in there, then it's earned its place. But actually, I found, for the most part, people say, no, I didn't realize that was already there. It doesn't really need to be different, just use the existing guideline. Suddenly there we've helped standardize and ensure consistent behavior across the application, the product that we're making. We found this throughout Slash Programs' responsive refactor as well over the past 2 years. At the start, we were working with our design team, and we were getting image mock-ups. And when we looked at these, we said, actually, hang on, that's not the standard you provided before, that's not the standard you provided before, does that need to be different? And the answer was, for the most part, no, because the designers were not quite yet familiar with what they were giving us. We were coming from like a team of different designers that weren't quite talking to each other. But then eventually, as the redesign rolled on, the design team got more familiar with what already existed, and they understood the idea that, hey, look, there's this standard system already in place, so they don't need to actually waste time designing full-page mock-ups for every single page that we have. So they started sending us wireframes instead, because they know that they don't need the fine detail of every single item within the page, just those broad blocks of these objects going around. This eventually came to a head towards the end of the project, when, for one of our final page designs, we received an email. Just text, no pictures, no nothing. And it said, all right, it's going to be 6 of these objects, lay them out in the standard grid. And we knew precisely what that meant from the text. We didn't need a mock-up to implement that, and the designers didn't need to spend a load of time showing us a visual representation of what they wanted, because they could just describe it to us in 2 very short sentences. And that becomes incredibly powerful, because it saves time for everybody, not just developers, but designers as well. So these design systems are actually completely agnostic to any kind of code you were to write. This sits above, at a level above that code. A single design system can be implemented in HTML, in Android applications or iOS applications, and your design system will probably say something about environment level conventions. So like, oh, on Android it should have Android style buttons, on iOS it should have iOS style buttons, to avoid that weird uncanny valley where your app doesn't fit your operating system. But the inverse of that is also true. A single design system can be implemented multiple times within the same environment. So, for instance, the BBC is a massive organization made up of a whole bunch of disparate product teams. There's news, sport, programs, iPlayer, knowledge and learning. Yeah, the list goes on for this. And the dev teams for all these products don't really speak to each other all that much, because they're solving, for the most part, quite different problems. So, and there's a standard BBC GEL team, the Global Experience Language, which is the style guide for use across all of the BBC. And that defines a set of standard grid layout and standard typographic layout. And they provide a reference implementation for that, but those individual application teams don't need to go and use that if it doesn't fit their particular style. As long as each implementation adheres to the design system above, then implementation details don't really matter. It's not a problem if that team's using Sass and that team's using less, or that team wants to format their class names in a certain format versus somebody else. Doesn't matter. They are free to have those differences as long as they adhere to the design system that sits above. So, quick conclusion: design systems, they formalize the concept of standard patterns by giving them single names. They help enforce consistency, and they don't actually care about implementation in the ways that I've just talked about. If you want anything more on design systems, then Kaylee gave an excellent talk last year entitled Bridging the Gap Between Designers and Developers, based on his work at The Guardian, which is a large UK, US, and Australian newspaper. And a lady called Alla Kolmatova spoke earlier this year at Responsive Day Out, talking about the process of modular design to a company called FutureLearn. I've got links to both of these talks at the end of my talk, so please check those out. They're very interesting. And now, once you've got all these ideas for your common patterns, you can then start writing them into your application, which is probably the more meatier part of this. You start creating your HTML and CSS fragments within your app, and reusing those styles all over the place. And by leveraging your prior work, you can vastly reduce the amount of dev effort required to create new templates, what I've been alluding to earlier. But that's merely just creating a library of components. There's nowhere there inherently to demonstrate these components without any other context around them, or there's not inherently any documentation on how to use those either. It's not having a library isn't massively valuable if the other members of your team don't know that these items already exist and they can use them in the new features that they're developing, or indeed how to use them even if they do know they exist. So you've actually got two layers of implementation that sit above your design system. You have your component library, which is your implementation, and then you have your style guide, which is the documentation of that component library, which includes examples of each of those components within isolation. So your component library is very broadly split into two types of thing. You'll end up with a set of CSS-only foundations, and you'll end up with things that require HTML templates in addition to CSS. Those foundations pervade your entire site. They're not so much about concrete blocks of content. You can't go to a page and say, that block. These things define the rhythm and the brand of your site. They're your things like your coloring, your typography, your grid system, and form elements, things that apply on thereabouts per HTML element basis. And then you've got the things that sit atop of that. The items that are rendered using those visual foundations, and these tend to correspond to your domain objects. Domain objects being the things that you use to model your problem domain. So for instance, in program, so these are like entities in your database. So for instance, in programs, we have things like programs and broadcasts and galleries. A travel site like TripAdvisor would have things like trips, hotels, and flights. And these items require a whole bunch of HTML to output, in addition to blobs of CSS, and they probably also have a bunch of logic attached to them. So it's not just going to be a piece of static HTML that you drop into your site. You'll want to inject the title of your program into that block of HTML, for instance. And these are HTML partials rendered in the templating language of your choice. And now, being a very enterprising sort of people, many devs have gone and created tools to optimize the creation of the style guides that sit above these component libraries. You've got things like KSS, Style Doco, Style Down, and Hologram. And they all work in a pretty similar way. You write some doc block comments in your CSS file that will provide a description of how to use that CSS component, run a generator thing, and it'll spit out a bunch of HTML files that you can put wherever, and that's your documentation. And this is pretty neat, but it's only actually doing half a job, really. It covers the CSS-only parts, but it doesn't have any kind of concept around what to do with your more complex HTML templates. And that's actually what most people are going to be using when they come to create new pages within your site. And for me, that means that's a bit of a non-starter. It's only going halfway. But on the upside, manually creating these documentation pages in your app is actually pretty easy. Now, it's a new controller and a view file for each page of documentation you want to write. Just write your documentation within the view files. You don't need like a fancy CMS backend for this. Just write some text in your text editor and save it. You remember the HTML editing days of yore when you could just open up a file and type things into it rather than having to do all this abstraction. And this is pretty much what we've been doing for Programs is Refactor over the past 2 years. It's worked out pretty well. We've got a little corner of our app visible at www.bbc.co.uk/program/styleguide. Very imaginative, I know. And there have been a few little issues here and there, but for the most part, nothing has really warranted the time to go and fix this. This has now changed, so things are getting interesting. So we're now moving into the new world. The /programs team is now working with the /radio team on a new version of iPlayer Radio. So this is on-demand listening of radio, somewhat unsurprisingly. And we want to share a single visual style across these two distinct applications developed by two different teams. This means that we need to start abstracting our component library and our style guide out of the program's app itself and into a neutral location. And this gives us an opportunity to do a little bit of a rewrite using all of the lessons that we learned when we were doing this first time round. Again, iteration and learning as we go. We didn't quite know what we wanted the first time round, but now we've done it once we've got a bit of a better idea. So we've got a chance to do a bit of a more stricter, a bit more formalized approach. So we wrote our new component library, which we're calling Armen. There are reasons for that, but it's mostly based around really bad puns, so I'm not really going to bother explaining that. So we end up with a set of Armen components that are used to build a trio of applications. There's the programs application, the /radio application, and the style guide for Armen itself. So before I want to go into what Armen contains, I want to talk a little bit about the tech we use. Not because the tech itself is particularly interesting, but because the tech stack that we use is a result of a couple of questions that we asked ourselves at the very start of this project. And I think these questions are important to ask, and it will differ from team to team. So we're using Composer as our package manager and Twig as our templating engine. Our corner of the BBC is a PHP shop, so let's use PHP tools for the job. Composer is PHP's equivalent of Ruby Gems or NPM, and Twig is a templating language like Mustache or Handlebars, Jade or things like that. So we're distributing Armen as a library through Composer. Applications depend upon that library, pull it in at build time, compile, run. And this means that potentially the applications that use Armen can get a little bit out of sync if one's released a newer version with the newer version of Armen, but the other one is still on an older version. But we decided actually, that's not too much of a problem. We've only got 2 applications. It's going to be quite straightforward to keep them in sync. We could have gone down an alternative route for this. GovUK, the UK's new government digital service, have gone down a route where they provide a web service that returns the latest template for each component that you ask for, which means that you get to update your component library centrally in a single place, and you don't need to go and deploy every individual application. And this is quite neat, but actually that's a whole load of extra engineering effort we didn't really want or need at the moment. You've got to build that web service, you've got to manage it, you've got to deal with all the client libraries that make requests to that web service, cache it, and do all that invalidation side of things. Which actually, that's not really worth the time to develop it for us. So we've not bothered. Maybe that's different for you if you work at a company that's even more disparate than the BBC, which it turns out is possible. but you need to be either working for a nation state or the Financial Times. So for the templating language, we chose Twig, as I've already mentioned, mostly because it integrates best with the frameworks that we're already using, which is Silex and Symfony. We had a look at Mustache and Handlebars. They would be really useful if we wanted to do language agnostic implementations. So if we wanted to say, if we wanted to move to a new language in the future, then we could reuse our templates. Or if we wanted to do isomorphic rendering of our templates using the same templates on the front end and also within the browser and also on the back end. But it turns out we actually don't really want to do that on our side. We prefer loading blobs of HTML through Ajax rather than writing complex client-side scripts. This works well for our case. It might not work for yourselves, but look into Mustache if that is a useful thing for you. So there was no big win for us, so why waste a whole load of extra time and dev effort to not actually get anything out of it, so we didn't really bother. So as for Almond components, for our naming convention and folder structure, we pretty much followed Brad Frost's atomic design, which which splits your components into 4 categories. You have atoms, molecules, organisms, and templates. So atoms are the fundamental pieces of your design, those colors, typographic, the stuff that styles a single element. And as they're single elements, they're blobs of CSS only. You don't need a HTML template for a single H1 tag, for instance. Molecules are the next step up of that, and they group a set of atoms, and when they're combined, they do something a little bit more concrete. So things like, say, the media CSS object. It's a visual abstraction containing multiple HTML elements. So combining that into a single place makes sense. Alternatively, they're the rendering of a single element with a piece of simple data inside them. So for instance, we have a molecule that displays the duration of a particular piece of content. You pass in a duration and it will spit out a span tag that says how long it is. And we do that because we have a standard way of rendering a duration. We want to say an hour and 30 minutes instead of 90 minutes. We want to reuse that concept of how to do that across our site. We want to ensure that consistency. Organisms become the next step up from that. These represent the largest section of your interface. It's at this level that you start expressing your more complex domain objects, so your programs and your broadcasts, your articles in the programs world. These almost contain HTML with quite a bit of logic in them. You want to be injecting text from your domain object into that HTML template to go and render it. And then finally you have templates, which are the final step in this chain, and they're used for structuring a layout of organisms. These are mostly what I term aggregations. They're ways of showing lists of organisms as a bit of context. So the idea is it accepts an array of those organisms and displays them in some way. So for instance, we have a grid aggregation that takes a set of any type of organism and we can then go and display that in a grid. This means that we can say, we can have a grid of program organisms, we could have a vertical list of broadcast organisms, or we could have a carousel aggregation of many gallery objects. And by decoupling what a single item looks like versus how to display a set of arbitrary items, you end up with a multiplicative effect there, because you can then easily combine any 2 single items and ways of displaying there. If you add a new single item, we've added a new way of displaying a single broadcast, well, we can display that in many different ways already, because we can use that with any of those aggregations. So as for folder structure, looks a little bit like that. As this is a abstracted library, we've said, we're going to have a single folder hierarchy. where everything that refers to a single component all lives within the same folder. There's not really any value for us in splitting out our content by type and having a /stars folder and a /templates folder when there's only going to be one file inside each of those. And when we're working within the mindset of I'm working on a particular object rather than I'm working on all of the style sheets. And we've also realized that a component doesn't only consist of a CSS partial and a HTML template. As you can see there, well, we've got the program CSS there and the program HTML twig, which is the template. But there's also these two other things, presenters. So each of these components should have a few extra items as well, potentially. So any component that has a template where variables get injected into it should also have an interface to that template and a presenter class that implements that interface. This interface provides a way of formalizing the data object that we want to pass into the template. By using our language's type system, we get to be able to assert that we've got various methods available, and then that helps us ensure that the template won't throw an exception if we throw in a piece of data that's missing some method. You know, if you were to pass just like a standard object or associative array in there, then if you miss out a value, it'll explode and you won't know why, whereas this lets us catch that at compile time. So for instance, if our program template needs a title, a player URL for when we link to the playout page on iPlayer, a synopsis and an image, then it would have an interface that looks like that. Get title, get player URL, get image, get synopsis. And now we can safely know that any object that implements this interface can be successfully rendered by the template. This helps solve a big issue that we had with our prior system, where it wasn't always clear on what information was needed or not needed by a template. This gives us an explicit list of all values needed by that template, so we can be certain that we're not missing any. So we also need a presenter class to be a concrete implementation of this interface. This is where we place all of our logic that deals with transforming our data domain objects into the data that we need within our templates. This additional layer is useful because while many of the values in that the template needs can be passed directly through from our data object that came from the database without any kind of modification. So for instance, if we have a program presenter, then get title comes straight from the program object, which is our data, the object that came straight from our database. We can just say, oh right, it's the title, render that out without any kind of fiddling. But often, in many other cases, that mapping isn't quite as trivial. Often there's going to be purely presentational concerns that have to go and make decisions based off of the data object. So for instance, our program template needs to know what the playout link should be. This URL is different if it's a piece of TV media or radio media. They go to two different places. This doesn't belong in your data object that comes from the database because it's an artifact purely of presentation. But at the same time, it doesn't really belong in your template either, because then your template ends up getting quite crufty and hard to understand because you're putting a load of extra logic in there. This layer provides the place to put that as that intermediate tree, so we can write a simple bit of PHP there that will say, hey look, if it's a video episode, show this URL. If it's not, show some other URL. This solves the biggest problem that we had when we were with our old system. Because our templates were getting very hard to read in some cases, because there was a lot of this sort of logic intermingled with all our HTML. It became very hard to read, and it became a bit of a chore to work with. It was manageable, but now we've got a clean break to do stuff again. This is the way we'd rather do it. So to help solve this, Armin has introduced a pretty simple rule. I've ended up terming this the single conditional rule, because the person that came up with this couldn't think of a good name. So, that kind of fell to me. Incidentally, after that joint effort, I'm not quite sure which one of us gets to be called the thought leader. I think we're both hoping it's the other one, because that's a silly, silly name. Anyway, the rule. Single conditional rule. Wherever possible, all logic should be done in the presenter. Template logic should be based upon a single conditional clause. So logic in your templates is unavoidable. You're always going to need like simple if statements and for loops. But we shouldn't, but we can and we should try and move the majority of the complexity into the presenter class. So we say if a template has an if statement that's got more than one conditional on it, so if this and this or this, then that should be refactored into a method in your presenter. This means that your templates can focus on showing what's more important to you, your HTML content, because it's just if this, show something immediately. If I think. So quick recap of that, you have your data domain objects that come from your database. They pass information to your presenter classes, which then go and provide display logic for your templating. This also has a useful side effect because it means that your presentation layer is decoupled from your data layer. And if, like us, you're in the middle of moving from one data source to another, then you can create a new presenter class that can assume your old data source, have it implement the same interface, and you know that what you get out the other side is good and still working. You don't have to go and change your view logic if you're changing your data logic as well. So using presenters also has another quite useful effect. Now that all of your logic's in a class file in whichever language that you choose, then you can go and unit test that logic like any other class in your system. So your presenters should be immutable. Once you've instantiated them, there should be no setters. You can't change the data within them, which means that testing them is actually pretty easy. You've got one input, assert one output. You don't need to confuse yourself with changing state, and you get a whole load of functional programming style wins in there. So in terms of a simple presenter test, we can say, all right, basic test, instantiate our presenter, assert each of the functions that come out. Quite straightforward. So this is pretty useful, as now it helps us ensure that we're not going to break any backwards compatibility now that we're a library used by other applications. You know, it's not just our application that we have to know about, so we have to be a bit more defensive about this, and this serves as a useful first warning. So Almond's got another quite useful thing relating to testing in there as well. I found a Symfony framework module that lets you parse a blob of HTML and look for CSS selectors within it. So this means we're actually unit testing our templates as well. So, for instance, if we've got an option in there to say, don't render the program synopsis, then we can look at the HTML and assert that HTML element doesn't exist. So where are we? So that is creating a program presenter. It is rendering that template with that program presenter and saying, is the element program __ synopsis there? No, it isn't. Good. Test pass. Again, this is pretty trivial, but it's a useful first canary to make sure we don't break any backwards compatibility. So, in conclusion, formalize your design system. Write it down, make it something you can point at and refer to, and make sure people know about this and care about it. Move all of your presentation logic into presenter classes, so then your data objects can focus on data concerns, and your HTML templates can focus on HTML output. That has a side effect keeping your HTML templates clean. And once you've written this properly abstracted tiered system, whose parts can be tested in isolation, go do those tests as well. Quick little link dump, the two talks that I mentioned earlier about design systems, Brad Frost's Atomic Web Design, and the Almond documentation itself. So this talk was titled The Step After Styleguides, and I've kind of misled you. There isn't a step after Styleguides. Your style guide is the documentation of your component library, but maybe your component library can contain more things than just HTML and CSS fragments. I've been Ben Scott. That's all I've got for you today. Thank you very much.